And finally, you check this. If you want to pause the video, go ahead and pause it. Okay. So where is this series? What am I going to do with this series? So let's isolate the non-alternating part again. So 1, 3, 5, all the way. It's the product of all odd numbers starting from 1 all the way to 2n minus 1. And this is the product of numbers 1, 4, 7 following some pattern 3n minus 2. Okay. All right, for this one, I just wanted to write a n and a m plus 1 clearly for you guys to see what's going on. This is mostly for part B, though. I mean, the second part of the alternating series test. But let's start with first part. So limit of a n has to be 0. Right, for the limit of a n, I'm going to rewrite this. So here I have 1 times 3 at the top. I'm going to match it to 1. I have, let's see, I have 5 here. I'm going to match it to 4. Okay. I have 7 here because the next term here is 7, so the top is going to be 7. So essentially, here, this term is matched to that, this term is matched to that. It's always like the fourth term in the top is matched to the third term in the bottom. So when you go all the way down here, the last term here is going to be matched the one before this. Okay, the one before this. What is that? Since there's like the difference is 3 between each consecutive term, so this should be 3n minus 5. And the last one is not going to be matched by anything, right? So 3n minus 2. Okay? So in other words, these numbers match when you pass the limit. So this is going to be the limiting behavior is going to be a limit of this part here. 1, 5 over 4, 7 over 7, 2n minus 1, 3n minus 5. Times 1 over 3n minus 2. So this implies that since these are all like terms, this is going to be a finite limit, whereas this one is going to take you to 0. 0 times a finite number is going to take you 0. Okay. So this is hard to see. Just you can pause the video and keep thinking about this question. But the limit of the an, so an is here, right? This is an. So this part here is an, right? The non-alternating part. Okay. So an converges to 0. How about an and an plus 1? What is the sort of like comparison between these two to prove that an is decreasing? So let's check that out. But I write an and an plus 1 explicitly for you to see. So this part of an, let me just use a different color. So this part of, well, this is already an, but this is already an as well, right? So in other words, what I'm trying to say is that an plus 1 is an times 2n plus 1, 3n plus 1. So whenever I multiply an by 2n plus 1, 3n plus 1, I get an plus 1. So now the question is like, who's bigger? Well, since I multiply an by 2n plus 1, 3n plus 1, so just imagine for any n value starting from 1. So for example, for n equals 1, this term looks like 3 over 4. So you're multiplying a number by 3/4. Well, you're going to get a smaller number. For n equals 2, well, that's going to be looking like 5 over 7. So you're multiplying a number by 5 over 7, you're going to get a smaller number. You see what I'm talking about? Like, if you just keep going like that, an plus 1 is going to be less than an. So think about it. You can pause the video and think about it by yourself. But every time you multiply an by 2n plus 1 over 3n plus 1, you get a smaller number, which is an plus 1. So that implies that an is a decreasing sequence. All right. So going back to this problem here, that both conditions are satisfied, right? Both conditions are satisfied. So this series is a convergent series. This alternating series is a convergent series. This is the end of the video. Thanks for watching. I'll see you in another video. Bye.